Derrick Hogan here with Northwoods Technical College doing some work for Practical Machinists. When I left you last time, we were working on these brake levers. Let's pick back up and see how they're going now. Now, one of the hard things with working this right here is trying to keep yourself out of this surface right here, because you don't want to scar it. At the same time, you got to remove all this right here so the 1-inch bar will fit down into there smoothly. That's one of the little things about this piece here that's really easy to underestimate when you're going to look at it to do the job. Now that you got the radius on this blended out and filed down, you're faced with the challenge of holding it. Without a fixture and some special tooling, there's no real easy way to hold this piece here. You have no flat surfaces. The surface you see here is angled. The surface you see here has an angle and a rate, and your radius is here. You got radiuses here. So there's not a great way to hold this piece. So as you can see right here, you can even see the drawbacks here. The clamping taking place right here is actually on the back of this. So once again, if I didn't catch that, that could be problematic with this. Now, what I'll probably will do for this right here is to centralize my clamp pressure. Is I'm probably going to put a pin right in this area right here, a small pin, so that I can actually get my clamp pressure towards the center of my part. Now, that's not going to be ideal because my part would be able to potentially move around that pin, but I think it's going to give me a better clamp than doing what I'm currently doing right here. Once again, dealing with the headache that this is, you now see the problem with this method. As you can see, my dowel pin is in there. It's going to keep my pressure centralized to one location, but it's not sitting squarely on this side, so it's sitting there at an angle. So the combination of that there is giving me issues when it comes to trying to clamp this piece. If I tighten this down, it's going to potentially cramp it right here and put some damage to the surface. So I'm going to have to come up with another idea. Once again, you got to remember, these are a part that the customer would not expect to be as complicated as they're going to be. So you've got to try to work with these as best you can and try to figure out a way to economically do a piece like this, which there's not really an easy economically way to do this piece. One of the things I'm working on right now, to get rid of this little high spot here, I brought this back over to my bench vise. I'm working on removing a little bit of material here to get it where it clamps a little bit better. Once again, this is a casting here. It does have to clamp, and I can't really start affecting it too much dimensionally, but at the same time, there's some imperfections when you're dealing with casting. So sometimes getting this to work involves a little bit of extra work to get the surfaces where you can actually clamp on them. I've done a little bit more work on this. Some decent amount of time involved in this so far, and I hadn't even gotten to the point of actually clamping the piece successfully to mill it. So it's better. It's probably workable. When it clamped down, it's not secure yet. So you can see there's some more material I need to take away. I need to take away a little bit more material from this area right here so that it actually will be secure enough to be able to hold. If I try to drill this now, it's just going to give me problems. So back over to the bench, take a little bit more material off. Okay, now I've got my piece clamped. You can see I got it much more secure. This would actually hold it. And I had to take away a little bit of material from this corner down in here. So I get the focus on that. So that it would be able to be clamped. Now, next thing I would do is go back to the procedure I had earlier, where I used my level to give myself a roughly ballpark. As you can see, I am nowhere near being true right now. So I need to be roughly right over here for this machine. You see how the machine itself hugs the right side of the level. So once again, this is not going to be my final method. This is just going to be the method I get myself with an indicator travel. So I'm going to loosen this right here and adjust it accordingly. Loosened it up, position the level, tighten it down. Now the indication process is going to be very similar to what we saw on the other piece. And then the hole, we're going about machining these two holes. So I'm going to skip the rest of that because you went through it. Remember, we used that little piece that I had machined. Actually, you know what, let me get a piece. I'll be back in 1 second. If you remember from this piece right here, the previous piece that we made using this blueprint right here, this, missing a whole lot of dimensions, but we were able to make it work. We took and made an aluminum piece like this, so I had something to pick up on. That allowed me to drop this down into the radius here and be able to push it down against it and have something I could pick up on. So I actually had a chance of getting a true reading. Now, if I had this piece to go back and do again, I would make sure that this dimension right here matched up to this width here. So this would just kind of slide down in there and be a nice easy fit. In this case right here, it doesn't. So I do have to put a little pressure, downward pressure, to keep it there. And I found it actually works best if I put a little bit of pressure towards the front. That way it's up against that, so it's going to be true when I go to do this. I could take a small clamp and clamp it here, as long as I had room to reach that. That's probably what I'm going to do when I actually go to machine this one in this case. So I'm going to keep my hands clear and free and safe in that regard. Now, another thing I need to do now is indicate this in. It's the same procedure I used on this piece. It's just on this piece right now. Once again, ultimately we're going to where this piece has all the features that you see right here made into it to go about making the this part of the brake clamp for the brake calipers. So just like on the other piece, I got my indicator and I've got it zeroed out, and I'm going to move across and see how true this is or how untrue it is. So you can see my square got me close, got me in 5 thousandths, and that's not bad. It's not quite as good as it could be, but it's not bad. So what I'm going to do is take and bump it over here to bring this down to size. Okay, now I've got this relatively close to being flat. It's kind of tough to indicate because where do you pick on this surface to have my zero be? Right here is about middle, and I'm about 2.5, 3 thousandths there. It jumps a little bit there. Move over to the other side, and I am about the same here, about 3, 4 thousandths there. If I keep going, it will move up some more, then it kind of starts coming back down. I'm going to call this pretty close, but one thing I am going to do on this right here that I didn't do on a previous one of these, I did, is I'm going to deck this right here. I'm going to take an end mill and come in here and just machine off that top surface just a little bit to give myself a flat surface so I can know everything else can be based off of. It's going to be a good surface. Once again, little extra things that you may not have considered when you initially agreed to do a part like this. All I'm doing right now is give myself at least a consistent flat surface I can use for future alignments on this thing. Take a little bit more. That should be good enough for what we're doing right now. Once again, it's not perfectly flat. There's a little bit of a spot right here, but overall for what we're doing right now, that gives us a surface that we can use to indicate in if we need to. In the previous video, I made this little piece here to have something that I could locate the center of this radius here, and took some 1-inch stock and machined away a little area that allowed me to drop it down in here. Now, a couple things I wish I had done differently. I could have made it fit a little bit better, but I was kind of in a hurry and I didn't take measurements when I was doing. I just kind of went visually as to what looked like it'd work, and I went a little bit too far. So what I have to do is physically kind of hold this in place, and I can touch off on both sides and find the center of it, just like we did when we're doing this piece. I'm not going to show that on camera because that's in the other video. I'll show you something else I ran into when I was doing this. As you can see, this little portion right here interferes with my ability to get over there and measure on this side. So technically I need to measure this on the front side. A little small thing, but once again, another little hassle of dealing with a casting like this. See, my number there is negative 1.504. If that was a significantly off of that, I would know I need to do something differently. So I'm going to go back to the halfway point here. The halfway point being 752. I'm going to re-zero there. Some machines have a half feature or centerline feature. Do not see one on this readout right here, but once again, it's just a matter of kind of doing the math yourself there. So I'm going to go X, ABS set, just going to zero it out there. Using this 1/2 inch end mill, I could not get myself down in between the jaws to measure there. So I went to the location where the hole will be. I'm going to work off of that. The hole on this piece right here is 1.219 spaced out. So I went to 609 there. And I got a number of 963. So I need to divide that in two and then go to the center line on that, just like I did on the other piece. Myself a little spot there. Go over to the other side for this next hole location. Myself a little spot there also. Now you can see there's another little problem here. We pulled off the center of what's the effective radius there. You can see how that hole is really close to the edge, and that is honestly how the other one turned out too. This piece right here was a little bit trickier to actually get everything located right on, because I felt like it was a little bit narrower than it was supposed to be. That is centered on the effective radius, but because you had so much material to take off here, it's easy to take too much off here. Another one of those little things that you would not necessarily notice when you're going to quote something like this, but you might run into. So once again, probably should have said no on this one at some point in time. Changed over my drill bit. Let's see how this drills. I spotted that deep enough that I have enough of the point connecting that it's not actually pushing off to the side as it goes to drill. It is pushing off the side a little bit right there. You can see it. Let me get over here if we can see it a little bit better. So what I'm going to have to do with this, because of the fact I don't have enough material there to actually drill my hole where my hole is supposed to be located, I'm going to have to take and change this out for an end mill and go in there and plunge that out a little bit more to get it to where it actually cuts where it needs to be. Okay, as you can see, it's beginning to push off there a little bit in that corner. So I need to open that up. Well, the hole is 201 thousandths, number 7 drill bit. I don't have number 7 end mill. I could get 3/16, and that would be close, but it still give me a little bit of extra material on one side. 1/4 inch is gonna be too big. Well, if I was doing this on a completely manual machine, I would take a 3/16 and kind of step over a little bit and just kind of open it up a little bit manually that way. Well, since I'm not on a completely manual machine, I have some CNC capabilities to myself. I figure I will make that work for me. So what I'm gonna do is create a program. I'm gonna click program here, and I'm gonna click go to beginning here. I've already created it here, so it's got my X center -0.609, Y center 0, radius 1.005, direction counterclockwise to offset to the left with a feed rate of 4 inches per minute. That will go about cutting this for me. Now I have 2 axes of CNC on this. I have to control the Z myself completely. So I'm going to go about cutting this here so that I end up with a hole that's opened up to the right size at the top of it. Now what I'm going to do is one more run here at that set, little bit different depth setting, so I end up with a truly flat bottomed hole there. Once again, I'm using my end mill to cut this out to where it needs to be. So now I've got a flat bottomed hole, so I would go back and recenter drill this and go back drilling my holes. I'm going to skip ahead to the next part where we go about doing the counter bores on the back side of these. Okay, now I flipped it over. I'm using that machine surface I had to register my part. Right here, I just need to find these holes to be able to go about countersinking these holes on the back side. Now, finding these holes, what I ended up doing here was I took a gauge pin to fit down in my hole. And what I'm going to do is just move it down until I'm kind of like roughly right above it, and kind of visually looking at this area right here on the back. Trying to get there where it lines up pretty close. And I should be able to drop this down in there. Now, what I want to do now is unclamp the pin. I'm going to take this a step further. So my pin drops down in there relatively good. I'm going to take and run an indicator down here relatively close to the base here and see if I actually have this true or if I need to do any additional work on it. Before I go to indicate this in, I want to go ahead and zero this out on both my X and my Y here. I want to see how much it varies once I get done actually running the indicator on it, to see how close this method would have been, to see if it would have got me close enough to have something I could have used, or if I would have needed to indicate it in. Okay, I've got my indicator set in here. I've got myself a little bit of clearance here on the pin. I've got myself as close as I can really get. I can maybe get a little bit further down and still have some clearance. Let's see if I can get just a little bit more. Okay, I'll run it right here. Now, what I want to do first off is zero my indicator out. So I'm just going to put a little bit of preload into it and swing it around over here till line up on my 0 point. Okay, now I'm going to swing this around 180 degrees and we'll see where I'm at. Okay, so I'm about 8 thousandths off. Now, one thing I'm going to do is I'm going to make one little change here. This is because the machine I'm using right here. The machine I'm using here has no handle over here. So in order to adjust this, I have to come work on this other side over here, be able to see what I'm doing. So I come around over here. You see I moved about 15, 12, about 13 thousandths there. Half of that would be 6.5. I'll move half of that back towards 0. I'm going to re-0 here. Swing around. Still checking off. So let's see. Getting some weird inconsistent movements with this right here. I wonder if my pen feels pretty secure. I'm going to check my front side here. Some 0 here. Swing it around. What it is when I'm getting weird movements, is I'm off a pretty good bit of front to back. So I'm basically out of indicator travel this. I'm going to go back about half the travel. Re-0. Swing around. This is more like it. So this is a little bit more predictable now. 1/1000th out here. Re-0. There's an oddity with this indicator, by the way. If I turn my bezel counterclockwise, it loosens up. It doesn't actually move to 0. It's kind of annoying. Come back over here. I got a little variance there. Come over here, about 5 thousandths out. Move that back here towards 0. Check it again. I'm looking to get this within about, ultimately really I'm drilling drilled holes here. If I can get within about 5 thousandths, that should be pretty good here. So I'm 0 there, I'm 0 here, about 2 thousandths out here. So I'll move back half of that towards 0. Swing back over here, see how I'm sitting. About the same over here now. By the way, demo indication is a fun process. So about 3 thousandths out. For what we're doing, that will be sufficient. Once again, if I need this to be more precise, I'd have to spend more time on it. But that gets me located. Now, how much off are we? 4 thousandths on X, 12 thousandths on Y. X was better than I expected to be. The Y was not as good as I expected to be. So I'm going to re-0 both of these out. X, ABS set, Y, ABS set. This is my new 0 point right there. Now, my spacing difference on these right here is 1.219. I'm going to use that to create a program, once again, to cut my counterbores on the back side of this. Okay, now I'm going to go about changing my program to work for this right here. So I'm going to go to Program, right here, I'm going to go to beginning here, and we'll change it. My X center is now going to be 0 for the first one. Set 0 for Y there. My radius is going to be my radius of my counterbore. My counterbore in this case for a socket cap screw would be 315 thousandths. I'm going to give myself about 25 thousandths clearance there, so let's make it 340 thousandths, which would be 170 thousandths radius. All this rest of this stays the same. I'm still going to use tool 1. I'm going to change tool 1 to be a different size diameter. I can use a little bit bigger tool here instead of using the 1/8 inch cutter. I'm going to go with probably a quarter inch cutter in this case. So all the rest of this should be pretty decent there. To change my tool, I'll click mode. Here I'm going to go over to setup, and I'm going to go to tool table here, and it's got my tool here, 0.125 right here, finishing end mill. I want to change my diameter here, so I'm going to scroll data left. Yeah, use the touch screen, start going for this, touching the screen there. So 0.250 here, and I'm going to go to ABS set for that. That changes my diameter to a 1/4 inch. And it's going to use that there to go about creating my tool path to rough this pocket in. I could use a counter bore here to do this. The problem's going to be this side's going to be relatively easily. Counterbore that with a pallet. That's going to be a little bit trickier to do. So by doing this right here, using my program here, which I can get back to mode, program, go to beginning here. I've got this right here, and I'm going to create another profile for the second one, which will be at the 1.219 dimension there. Be exactly like this, just in a different position. It makes it a lot easier to run it this way here than it would be to try to get a counterbore to deal with this right here. I'm going to touch off kind of this back corner back here, and I'm going to move down about 400 thousandths is what I ended up doing on the other one here. So I've got my thing ready to go. Load tool 1. I'm going to turn my spindle on, adjust my speed, and I'm going to feed, mash my button to get it there. It's ready to set Z. I'm bring my table up until I touch, and I'm going to go down about 100 thousandths to start with. I was thinking 125. Now I'm going to mash my button to make it run. It's going to go about, oh, it's not that. It's going to repeat here again. It's going to go down another 125 thousandths. Mash the button again. Do the same thing one more time here. As you can see, it milled me a pocket down in there. That's going to have clearance for the head. Now, what I would do for the next one is change my location of my pocket on the other piece. Now, one little change I wanted to make here is the previous one we did right here. You can see where it broke into that area right there. I don't want to have this happen on this one right here, so I'm going with just shallower depths. I measured the thickness of this boss right here, determined it to be about 225 thousandths. So my total depth on this counterbore right here is going to be 225. I've already been 125, so I'm going to go down about another 100 thousandths on this right here and then finish this piece up. finishes up this side. So now we have our piece. It's been milled and drilled to accept the clamp portion of it. And we'll go on to the next portion, which will be the slot. Right in here, the hole right in here, and the hole right in this area here. So you kind of get an idea. This is one of those things that's be really easy to underestimate how long it would take and to overestimate how easy it's going to be to hold. It's proving to be a pretty challenging little part.